it's a wild out there question, but what year, how far away are we from a AI system being a collaborator on a proof that wins the Fields medal? So that level.
I gave a prediction in print, so by 2026, which is now next year, there will be math collaborations, with AI. So not Fields medal winning, but like actual research level math papers.
Like published ideas that are in part generated by AI.
Maybe not the ideas, but at least some of the computations, the verifications. Yeah, I mean,
has that already happened?
Has already happened. Yeah, there are problems that were solved by a complicated process, conversing with AI to propose things, and the human goes and tries it, and the contract doesn't work. But if I propose a different idea, there's a big hump to overcome right now. I mean, it's like self-driving cars. Right. The safety margin has to be really high for it to be feasible. So so there's a last mile problem with a lot of AI applications that they can develop tools that work 20%, 80% of the time, but it's still not good enough, and in fact even worse than good in some ways.
I mean, another way of asking the Fields medal question is, what year do you think you'll wake up and be like real surprised? You read the headline, the news of something happened that AI did, like, real breakthrough, something.
Yeah, this decade, I can see it like making a conjecture between two things that people thought was unrelated.
Oh, interesting. Generating a conjecture that's a beautiful conjecture.
Yeah, and actually has a real chance of being correct and meaningful. And the current models struggle a lot. I mean, so a version of this is, the physicists have a dream of getting the AIs to discover new laws of physics. The dream is you just feed it all this data, okay, and here's a new pattern that we didn't see before. But it actually even struggles. The current state of the art even struggles to discover old laws of physics from the data. I mean, or if it does, there's a big concern of contamination, that it did it only because like somewhere in its training data it already somehow knew, Boyle's law or whatever law you're trying to reconstruct. Part of it is that we don't have the right type of training data for this. So for laws of physics, like we don't have like a million different universes with a million different laws of nature. A lot of what we're missing in math is actually the negative space of. So we have published things that people have been able to prove, and conjectures that ended up being verified, or maybe counterexamples produced. But we don't have data on things that were proposed, and they're kind of a good thing to try. But then people quickly realized that it was the wrong conjecture, and then they said, "Oh, but we should actually change our claim to modify it in this way to actually make it more plausible." There's a trial and error process, which is a real integral part of human mathematical discovery, which we don't record because it's embarrassing. We make mistakes, and we only like to publish our wins. The AI has no access to this data to train on. I sometimes joke that basically AI has to go through a grad school and actually, go to grad courses, do the assignments, go to office hours, make mistakes, get advice on how to correct the mistakes, and learn from that.